Hi, welcome to our 24th tutorial on Erlang. Today we're going to discuss socket programming using UDP and TCP. Let's get started by opening terminal. I'm using Ubuntu today because I just find it a lot easier, plus just want to try something new. Now that we have our Erlang terminal open, the first example will be using a UDP socket. And for those who don't know, UDP stands for User Datagram Protocol. UDP is a connectionless protocol. It's unreliable because when message is sent, we cannot know if the destination has been reached or not. But in return, it is faster than a TCP connection. So now that we have the virtual machine running by calling ERL, the first thing we need to do is to open a UDP socket. And we're going to do this by calling an Erlang function, an Erlang module called gen_UDP, and call it the open function. That returns a tuple that contains OK and the socket. So we need to catch the socket by creating our own tuple, and we're going to have OK and socket in it. And we're going to call gen_UDP, and we're going to call the open function. Open takes in one or two parameters. The first one is the port, and the second one is list of options. So if we want to set our port to port 9000, and we're going to put a list of options in here. The first option we want to set is we want to specify the type of data we want to receive. Do we want to receive a list or do we want to receive binary? And for this, I'm going to use binary. The second option we want to set is whether we want to use an active mode or a passive mode. Basically, an active socket are connected with the remote active socket through an open data connection. If this connection is closed, the active socket at each end is destroyed, while on the other side, a passive socket are not connected. Instead, they wait for an incoming connection that will spawn a new active socket. So for this, what we want to use is a passive socket. So we're going to set active to false and enter. So now that we have our socket, the next step is to await a message. And to do this, we simply call gen_UDP, and we're going to call the recv function. The recv function takes in 2 to 3 arguments. The first one is the socket, the second one is the length, and an optional third argument is a timeout. So if we put 200 here, it's going to time out pretty quickly. And here we go, error timeout. So what we want to do is actually remove it, and this is actually the reason behind the second terminal. In the second terminal, we're basically going to create another socket. So OK_socket, and it's just the same step as the other one, gen_UDP and open function. Send it to 9001 because we want to send the message from a different socket to the 9000 socket. And the same thing, we're going to set binary, and we want to set it to an active mode. So active, true. And we have our new socket. And now the main point of the second terminal is to send a message from that socket 9001, to a second UDP using port 9000. So we're going to call gen_UDP, and we're going to call the send function. The send function takes in 4 arguments. The first being the socket, the second being the IP address, and since we're on the local host, we're going to call 127, not a dot, 0, 0, 1. And next we're going to specify the port that we want to communicate with, which is going to be port 9000. And finally, our message. Our message is going to be hello from UX Learner. And we just send it by pressing enter. And as you can see on the first terminal, we have the message. Okay, the IP address, the port the message is coming from, and the message in binary that says hello from UX Learner. So what's next now is basically to close the connection by calling gn_udp, and we call the close function, and we want to close the socket. And we have socket close, and we do the same thing for the second terminal, and then we go towards talking about TCP. Now that we have everything cleared up, we have to open a TCP socket. But first of all, I'll just give you a brief description about TCP. TCP stands for Transmission Control Protocol. It's a connection-oriented protocol. It is reliable, although it is a lot slower than UDP, but it's more reliable. So the first thing we need to do is to open a TCP listening socket. And similar to UDP, we're going to call a function called gen_TCP and call the listening function, which returns a tuple. So let's catch that tuple by calling lsocket. So this is going to be a variable lsocket. And then we call gen_TCP and call the listen function. First thing about the listen function is similar to open with UDP. So by specifying the port, so port 9000, and by specifying a list of options. So for this, the same thing, binary, and we want to set the active to true. So we want an active mode. So I think I have too much. Yep. Okay. Now we have our listening socket. The next step is to set the listening socket to an accepting state, and we do this by calling a gen_TCP module and the accept function. So we're going to catch the accept mode by creating a tuple and a socket, and then we call the gen_TCP and we call the accept function. The accept function takes in 1 to 2 arguments. The first one will be the listening socket, while the second one is going to be a timer, similar to the recv function with UDP. So we're not going to put a timer on this, so we're just going to send the listening socket. So lsocket, and that's it. Now we go to the second shell, and we're going to create a socket, a connection socket, and then we're going to send a message. So first thing we have to do is to create a second socket. So we create a tuple and we have OK and socket. We're going to call, instead of TCP listening, we're going to call gen_TCP connect, because we're going to connect from this to the first socket. Connect takes 3 arguments: the IP address, the port we're connecting to, and a list of options. So first thing we do is to specify the IP address, and we're going to connect to IP address 127, the localhost 01. Second option is the port we're connecting to, and we're connecting to port 9000. The final argument is a list of options. So like before, we're going to use binary, and we're going to set active to true. So we want an active mode, and enter. And if you look at the first terminal, the connection has been set up. From here on, we can now send a message from the second shell to the first shell. So we can send a message by calling gn_tcp and call the send function. And first thing we need to do is to specify the socket, and we're going to send our message hello TCP from UX learner and enter. Nothing shows in the first shell until we call a function called flush, and voila, and we have shell received or shell got TCP, the port, and the message which says hello TCP from UX learner. And like before, we want to close everything, so gen_tcp close function, and we specify the socket, so a socket and the L socket, and we can free and unbind everything by calling f function, and everything is unbind. Now we need to proceed to an IDE IntelliJ, and we want to create a more improved TCP application that connects to a CSharp application. Now that everything is ready, what we have to do now is to create a new Erlang module, and we're going to call it socket project, and we make sure we have the right project SDK. Next, finish, and we want to do it this window. And then on the left hand side we have the project information and folder. What we want to do is on the source folder we want to add a new Erlang file called socket_server, and empty module, enter, everything is set up. The first thing we need to do for the purpose of this tutorial is to define a port. So dash define, and port will be the constant name, and the port we're going to use will be 9000, and that's our port defined. So next step is to create our first function. Our first function is going to be called the start server _server, and it's going to take 0 parameters. The start server function, basically we're going to open a listening socket, then we're going to spawn an accepting state followed by idling forever until we tell it to close. So let's get started by, first of all, we need to create a process by first thing we need to do is we need to spawn a new process. We call it PID, and PID equals we're going to spawn link. The reason why we're going to spawn link is basically to spawn and to link a process. This way we want to prevent the process from dying before it's linking. So we're going to call spawn link, and in this spawn link we're going to create an anonymous function which we're going to use to open the listening socket. So fun, and our anonymous function is basically going to listen. Okay, L socket equals the same thing, gen_tcp and listen, and we're going to specify the port. So now we're going to set the options. The first thing is to set it to binary, and we want a passive set, so we're going to set active to false, and false. So that's our first line of the anonymous function. The next line is basically to spawn an accepting state. So spawn, just a normal spawn, and spawn is basically going to call an anonymous function fun, and the anonymous function is going to call a function, an accepting state function, which we're going to write later on, but we're going to call it accept state. An accept state is going to take one argument, which is going to be L socket, and that's it. And we're going to end that anonymous function, end. And for this first anonymous function, we want to set the timer to sleep infinitely. Timer sleep, and we want to set it to infinity. So now it's basically going to idle forever. And finally, we want to end the function, anonymous function, and return a PID. Okay, PID. Okay, alright. That's it. So that's our first function done, and let's export this. Exported. Take 0 argument. Now time to write in the second function, which is going to be the accept state. The accept state takes one parameter, which is going to be the L socket. So now we create a tuple, okay, and a socket, which stands for the accept socket. The accept socket equals gen underscore TCP, and we're going to call the function accept, and we want to accept the L socket. See. Now we want to call a function to loop the accept state. So we're going to spawn fun and accept state, and we're going to give it the L socket. And end. And finally, we want to call the handler, which is going to be another function which we're going to write next, called handler. And handler takes the A socket, the accept state. That's it. So as you can see with this function, the connection L socket comes in and it starts a new process, which is basically calling itself again, the accept socket, while the actual work, the first one that comes in, is going to the handler, which I spelled wrong. Handler. Now we create the handler. So handler takes in the A socket. The first thing we do now is we need a way of restricting how and when messages can be put into the Erlang virtual machine. Basically a way of preventing flooding. To do this, we need to call a module called inet. So inet. Basically the inet provide access to TCP IP protocols. And with inet we want to call a function called setups. And here we're going to give it the socket, the A socket. And we want to quickly change the state to active once. We want to change active to once. And that is that done. Next is we create a receive, and we're just going to end the receive. End. So in the receive, we want to do some pattern matching. So the first pattern we want to match is TCP, comma, and the A socket, and the binary that we're going to receive. And the first binary is, let's say we receive a binary that contains only the word quit. So what do we do when we get a binary that contains only the word quit? What we want to do is simply to close the TCP socket. So gen underscore TCP close, and we want to close the A socket. And we're not going to loop the handler again, so it's closed. The next pattern we want to match would be, let me just copy and paste this. So what we want to do now is, let's say we're going to match a value. Well, we're going to start the string with a value equals, and then we're going to get the user to send in a value equals 10 through the sockets. So we have value equals, and now we want to get the value, the next string after value equals, and we do this by putting a variable x and slash binary. So anything else goes into x. And now what we have to do is we want to convert x into an integer, and to do this we create a variable called value, and value equals, let's say, list to integer, because what we're going to do now is basically convert binary to a list and then the list to an integer. So first thing is list to an integer and then binary to a list. I'm just doing some extra examples, and yep. Now we want a return value of the multiplication, so rt return, and we want to multiply. So let's just square the value we got, and the result is going to be given to return. And what we want to do now is we want to call gen underscore TCP, and we want to send the result. So send to, we want to send to the A socket and the message, which is going to be result sq equals, we send the return value, and in order to do this we need to return our binary. So we have to convert the return into a binary. We can do this by, let's call list, basically a reverse of what we had earlier. So it's going to be list underscore to or binary, and we're going to change that to integer to a list, and the integer will be the return value. So this way the answer is, we're going to return, the user is going to enter the value equals 10, and then we're going to return 10 by 10, so square of 10. And now finally we want to loop through the handler again. So let's copy and paste this. And finally, just to do an extra one, is basically same thing. Copy and paste this. It's something similar but different, just to give you a range. Binary message, MSG. So, and if our binary message, so we're going to do an if. So basically, if the binary message compares to a binary that says UX learner, we want to return, so we call gen underscore TCP send to a socket, and we want to return something, let's say A for UX, something like that, and else, so if that or else true, so this will always come, and we want to send something totally different, everything else. And so what we want to do now is to build the application, Actually, before that, I've just spot an error. Right here, we're meant to put options here, so brackets. And inside the options, we want to put active once. And also, let me just double check before I rebuild this. Okay, yes, the handler is missing. So basically, once the if function has been executed, it's going to loop the handler again. So that's perfect. Now we can rebuild it. Just to double check before creating the C# application, I want to actually test it running on the Erlang virtual machine. So the first thing we do is, once it's rebuilt, we just run the shell, and we're going to call socket_server, and we're going to call the start server function, and everything is running. Once we're in the Erlang virtual machine, we want to run terminal, call the ERL. And the first thing we do, like previously, we want to create a tuple and socket variable. Now we're going to create gen_TCP connect function, connect, and we want to connect to the IP address of the Windows PC, which is going to be 192.168.0.1 and 10. So we're not using localhost anymore, and we want to connect to port 9000, which was the one we defined. And finally, the options, which is going to be binary, and set it to an active state, or active mode, should I say, true. So curly bracket, square bracket, and now we have the sockets running. The next step is basically to send the message. So we're going to call gen_TCP send function, and we want to use the socket, and we want to send the message. First one will be hello, see what we get back, and flush, and we get back everything else. The second message we want to send will be, let's see, UX learner. I think that's what I said for the next one. And then we call flush, and we get A for UX learner. So the pattern matching is working perfectly. The next message we want to send is, let's say, value equals 2, and flush, we get 4, square result 4. And finally, let's quit. Flush should be finished by now, and shall go just TCP closed. If we try to send something else, we get error closed. Now that we know it's running, it's time to build our C# application. Now I have Visual Studio 2012 running. Due to the lack of time, I have went and created the C# client application, as you can see here, and let's take a look at the code quickly. In the code, we have thread functions, delegate functions, and event handlers. In the event handlers, we have the connect button click event, and we have the send message click event, and they all run in a thread. And now let's take a look at the thread functions. In the thread functions, we have the connect and the send functions, and as you can see, we've set up a client socket here, a new socket, and we've set the IP address to the server's IP address that it's running, which is 192.168.1 and 10, and we've set the port to port 9000. So that's a remote endpoint, and we've connected using the client socket connect function, and we've connected to the remote endpoint. And now let's go to the send function. Here in the send function, we have the string data. So we got the string from the text box, and we turn it into bytes, and then we send the client socket sends the data bytes. And as you can see, here is the received block, and we've received the information using the client socket, and using the decoder we set the values into the characters, and then we convert the characters into strings, and now we just set the string into the return message text box. If the value we sent is quit, we just enable the text box back again, and then we close the sockets. So let's run the application. So we have the application here, we have the connect button and we have the send button. Now if we look right here, we have our socket server running, and if we click connect, everything is fine. Let's call Ola and everything else. Now let's call UX learner. We get A for UX learner. Also let's call value equals 2. We get result requeue 4 and quit, and the connect server button enables again. Finally, if we try to send another message after quitting, we're just going to get an error: cannot access disposable object. Here is the code once more, just to take a look at it. So you can just pause the screencast. So that's it. Okay. So see you in the next tutorial.